Hi, welcome to the chain rule. This rule requires us to notice when we have a function inside another function. So for example, my first one here, if I have my g function, which is x squared plus 1, and my f function, which is root x, we can say we have our Fogg and Goff equations, if you remember these from pre-calc. Our Fogg says we put g inside of f. So we can think of this as f of g of x. So I've literally placed my g function on the inside of f. If I'm feeling fancy, I can go the other way, g of f of x. So this is our Goff. Now I put the x function inside the g. So every place we see x, we replace it with the function. In this case, it just turns into a line, but that's okay. So for these, we need to separate out our functions a little bit. So for example, if I have, I'm going to need to move this guy. Y equals the whole thing squared, x plus 5 over x squared plus 2, sorry, the whole thing squared there. We need to look for our outside versus inside function because we're always going to use the Fogg. Really, it's all the same. It's just a matter of if we're consistent with our notation, it makes life a little bit easier. I left my little, there we go, parenthesis behind. All right, so I like to start with the inside function. So inside, it's going to be my g. So that is x plus 5 over x squared plus 2. Technically, we have another couple functions inside there, but we're not going to go that deep. Then my outside function, which in this case is just my squared, so x squared. And if I were to go backwards and use these to the equation we just did, we'll get to the same thing. So on some of these problems, it might be easier to substitute something in the center. And a lot of times we're going to use u. So we could turn this into y equals u squared. It's less messy looking. You don't mix up your x's and your y's. And we can do our derivatives a little bit easier. I did not give myself any space this time. Okay. Chain rule. This is our last big rule. After this, everything else just uses these. So if we have an inscribed function or a function inside another, we take the derivative of the outside function times the inside as is times the derivative of the inside. So if we want to think of this as terms of u's, I should switch colors, sorry. F of u. Sorry, I'm childish sometimes. That was funny. All right, derivative of the outside is my f prime. Do not change the u function times the derivative of u, if that simplifies things for you. Again, there's always multiple ways to think about these. Find the one that resonates with you and go with that. As long as it's mathematically correct, it doesn't matter. Oof, I should have probably switched these, but that's okay. All right, we're going to find some derivatives. First thing, I'm going to rewrite my problem because this is easier to deal with. All right, so my f in this case is the outer function. We'll think of this as, I should be consistent with my notation. There we go. F of u is u to the 1/2. That's my outside function. So that means my g, my inside function, is the inside, x squared plus 1. Okay. I am going to find derivatives really quick. So the derivative of this is 1/2 u to the -1/2, and then times u prime. For this dude, I know my notation over there is kind of crappy, but it's just scratch work. All right, so y prime, the derivative of the outside is 1/2, leave the inside alone, to the -1/2, times the derivative of my inside, which is just 2x. So this is my f prime g, and this is my g prime. You know what? We're going to go back to x's, sorry. If not, it gets a little messed up. Okay. As always, practice with these helps. We could clean that up, but I'm going to choose to leave it for now. I leave the algebra to you. All right, this dude is a little more straightforward. I probably should have started with it, but alas. What's our outside function? X cubed. So I take the derivative of the outside, and at this point, I kind of ignore the inside. I pretend it's just an x. So that's how I would treat it. But I get 3 times the inside as is. Do not do anything to it yet. So take the derivative of that, leaves me with a 2. Now times the derivative of the inside. All done. I'm going to show the general power rule, which is actually what we just used. And then I'll show how we do our quotient rule problems like a product rule. In my opinion, the product rule is a little easier. I would always get less mixed up in it when I was learning calculus, so I always like to present that. You know, I mentioned that last video and realized we didn't have the last piece we needed for that. General power rule is what we just did. So if you have a function inside another function and your outer function is a power, you just take the derivative. So you bring your n down times the derivative of the inside. So this is our u prime of x. Oh, which is what I wrote right there. Okay, cool. All right, take a derivative. Y prime. Bring our number down. Leave the inside as is. 3 minus 1 is 2. Times the derivative of the inside, which is just 3 minus 4x. That's that. We're done with that. Okay, fun. I had more problems on here than I remembered writing. This is what happens when I do things at night. I am going to need more space for this guy. Okay, derivative of a tangent line at x equals 4. First things first, I don't have a y value. So, actually, yeah. Oops. Hi, kitty. Okay, so if I want my point, I have an x, I don't have a y. How do I find a y? I plug it in. My cat says hi. 4 plus 4 is 8. 8 squared is 64. And I do believe the cube root of 64 is 4. Let me check. Oh, good. Where's the cat? Oh, he left. Okay. All right. So my ordered pair then is 4. All right. We're going to need that in a little bit, but not yet. The derivative. Actually, one more thing before I do the derivative. I don't like this format. So I'm going to rewrite this as x plus 4 squared to the 1/3. Anytime I take a power to a power, I can multiply the powers. This is a lot easier to deal with. Still going to be weird once we plug stuff in, but for now, we're good. All right, y prime. Derivative of the outside, which is 2/3 x plus 4. Subtract 1, I get negative 1/3. Oh, hey, the derivative of the inside is just 1, so that's nice. Okay, so I get, is that right? Yeah. 2/3 times 1 over cube root of x plus 4. I could simplify more, but I'm not. I'm just going to plug in. So y prime equals 2/3 times 1 over cube root of 4 plus 4. Two-thirds times 1 over cube root of 8. Got like 2 more steps. Cube root of 8 is 2. I know my 2 powers really well. Equals 1/3. Cool. That's my slope. Point and a slope. We're good. All right, we'll switch back to black. So y minus my y1 was 4. We found that to start. Equals my slope times x minus my x1, which is also 4. And I have to do a little math here. I get y minus 4 equals 1/3 x minus 4/3. Okay, add 4 to both sides. Let's do a little side work. Negative 4/3. All right, common denominators. So multiply top and bottom by 3 gives me 12/3, which gives me 8/3. And that's a positive 8/3 at this point. And we're done. We have our tangent line. The more complex the derivative, the more complex our tangent line is going to be to find the spots, but you need a point and a slope. So with your point, you find your point just like you did way back in baby algebra. Plug your value into the original equation and find y. Your slope, that's where calculus comes into play. So find your derivative, then you're good. Once you find that, plug it in, get a value, you can find your equation. All right, is this the last problem I have on here? Okay, it is. I'm going to add one more. All right. This one looks a little more complex than the others, and yes and no. So if I look at this, I have a quotient rule sort of problem, and I have a chain rule inside of it. Let's attack it by a quotient rule and a chain rule. All right, so here I have the top and the bottom. The derivative of the top is 2 times 3x minus 1 times 3, so times the derivative. The bottom is 2 times x squared plus 3 times the derivative of the inside, which is 2x. And I'm going to clean this up one more step for each one. 6 times 3, or 9 to 18. X minus 6. This one, 2 times 3 is 4. So I get 4x cubed plus 12x. I skipped several steps there. Please feel free to go find them if you need them. Remember, our quotient rule is derivative of the top times the bottom minus the top derivative of the bottom all over bottom squared. I know I used F and G's in the last video, but tops and bottoms helps too. Keeps track of which one's which. It's a little more descriptive. All right, I'm gonna plug it in. Derivative of the top is that guy there times the original bottom equation minus the original top equation times the derivative of the bottom. I really hope I'm not making any glaring boo-boos on this. All over the original bottom equation squared. So I'm going to write this and then erase it a little bit. We have x squared plus 3 quantity squared, which just we multiply those. 2 times 2 is 4. So the more complex the problem, the more you probably want to break it into pieces for now until you get more comfortable with all the bits, and then you can kind of just do them all together. Honestly, take more time and get them right rather than trying to rush through. In the long run, it'll be better for you. All right, last one I didn't throw on here, but I realized I wanted to do that. Let's do a little bit nicer fraction. Over 5x minus 2. All right. This is a relatively straightforward quotient rule, but I can change this into a product rule if I so choose. As a challenge, if you want to go back and do some of the other ones from the previous section as product rules instead of quotient rules, please feel free. So I'm going to write this, bring my denominator up, and take it to the negative first power. Now I have a chain rule problem and a product rule problem. Honestly, mixing those two up isn't the worst. Okay. First times the second. So derivative of the first is just a 1 times my second as is. Plus, since it's product rule, the first times the derivative of the second. Here's where things get a little fun. Now I have to do the chain rule. So I bring this down. Subtract 1 from the exponent. Take the derivative of the inside. 3x squared plus 5. Okay. I do want to clean this up at least one more step because it's kind of nasty looking. All right, I have this -1 hanging on the outside. And you are x cubed plus 5x minus 2 to the -2 times 3x squared plus 5. At this point, we can bring our negative exponents down, get a common denominator, and with a little algebra voodoo, it will look like a quotient rule problem again. Neither method is necessarily superior. It's all about comfort level. Honestly, know how to do both because sometimes you want to use method A, sometimes you want to use method B. It really just depends on the problem. If this were me doing this problem, I probably just would have done quotient rule because it's a little more straightforward. I don't have to clean up as much. But for the really gross ones, I might do product rule instead. So you have options. All right, that is the end of this. I am going to stop it here and then do one more section today. Oh, here's the one.